Okay, let me explain a little bit about data frames, right? So what's a data frame? So here is an example of a data frame from the textbook from ISLR, from Introduction to Statistical Learning. So it's called OTA, right? So we can print it. Let me move it a little bit. So, and you see that the structure of this data frame is basically it just mirrors the structure of an Excel spreadsheet, right? So it has rows and columns. Every row is one observation. Every column is one variable. So the first column is miles per gallon, cylinders, displacement, and so on and so forth. So every column has a different type. Double means numeric. Double, well, I mean, all these columns are actually numeric, but it doesn't have to be. So the last column here is the name, is a factor. So factor is a categorical variable. So you could convert it to, say, a character if you want. You could add a new column. You can, I don't know, delete some columns and so on and so forth. But basically, a data frame is like probably the most common data type in R. In Python, you probably didn't see data frames because in Python, data frames are available if you load a special library called pandas. In MATLAB, if you know MATLAB, in MATLAB there are data frames, but they're not really popular. In R, it's like everything is done via data frames. To extract a particular column from a data frame, so you can do it in a different, well, basically there are 3 different ways to do it. So one thing is that you can use the dollar operator. So and then you just, I don't know, say MPG. When you do it like this, author dollar $MPG, you will extract just one column, right? So this is all observations of the variable MPG. Now, if say you do something like this, comma, yeah, the second index here, it represents columns, right? So it's say you write author space comma 5. This means all observations of in the 5th column, right? So this is going to be everything in the 5th column. Maybe let me just show you the whole author again so that you can compare, right? So the 5th column is 1, 2, 3, 4, 5 is weight, and these are all observations here in the weight column. So of course, if you write dollar weight, you will get the same thing. And if you write, actually, you can do it like this. So you can refer to a column using its name rather than its index, but not using the dollar operator, but just with square parentheses, right? So you can write weight here. It's going to be the same thing. Now, data frames, some functions that you can do with data frames are a lot similar to matrices. For example, you can extract just like particular rows and particular columns, right? So if you want to say extract rows 3, 7, and 25, and columns 1 and 7, I don't know, 1 and 10, and 19, this is how you do. Oops, something's wrong. Ah, yeah, because there is no column 19. There is no column 10. Okay, 5. How many? So let me write dimensions of author. So we have 392 rows and 9 columns. Okay. So 1, 5, and say 8. So this is 3 columns and 3 rows. Yeah, and this will be a smaller data frame, by the way. So if you type class of this thing, you will get a data frame. And I don't know, if you try dimensions, you will get 3 by 3. Then, so notice that here rows are not really named. Sometimes you can assign meaningful name to rows too. In this case, rows are just numbered. If you look at rows here, 1, 2, 3, 4, 5, and so on. But sometimes you can assign meaningful names to rows. You can extract, say here, if you want to select some rows and some columns, but you want to use names, column names, rather than column numbers, you can do. Sometimes it's more convenient. So if you say you write like year, name, I don't know, miles per gallon, you will get a valid answer, valid result. So the difference between matrices and data frames are that matrices can be added and multiplied. Data frames cannot. Right? So because data frame is like a static structure, but data frames are used a lot in R to I don't know, if you want to do a plot or if you want to train a statistical model, or I don't know, simple thing like if you want to do correlations, if you want to say, suppose that we want to look at just year, name, and well, okay, name is not going to work. This ways, right? If say we want to find pairwise correlations of year displacement and miles per gallon, so we can just apply the function chord to this, and it's going to return the 3x3 matrix of correlations. My point being is that a lot of native functions in R, they work with data frames. Or if say if you want to train a linear model, so like LM, you give it formula then data. So the first, let's say you want to do miles per gallon, and you want to use cylinders and say weight as predictors, and data is going to be our miles per gallon, MPG. It's going to work. Or if you want to plot, like let's say you want to plot, I don't know, come up with some scatter plot, ggplot. So you give it some data, auto, and then the statics is going to be x will be, say, I don't know, displacement, y is going to be mpg, and we want the scatter plot, so geom points. Again, the function ggplot takes a data frame as its input, and a lot of, like, I don't know, probably most of functionality in R is based on data frames. So which means it's very convenient to have your data as a data frame rather than something else, rather than just a vector or a matrix or whatever, most of the time. And then you can do all sorts of stuff. Now, throughout this course, we will teach you how to work with data frames. We are going to show you the modern package called tidyverse that is very, very powerful for all sorts of transformations of data and plotting, visualizing data. So, and all this functionality of tidyverse is designed for data frames. Okay.